In this lesson, we are going to graph some exponentials, and we're going to base it off of this. All right, so that's our basic exponential. Our a value is our initial value. This is going to be our left and right shift. This is going to be our up and down shift. So here are kind of all of our pieces. Our a value, well, first off, the fact that we have 5 halves, we are looking at a growth, an exponential growth. Our a value, which is our initial value, is there's actually a 1 in front of here, so our a value is 1. We're going to be going left 1 because of the plus 1 here. This is a left and right shift, always in the opposite direction. And the negative 3 is going to put us down 3. This is also our horizontal asymptote. So y equals negative 3 as our horizontal asymptote. So I know that's going to happen. Might as well just kind of throw that into the picture. All right, so we have an initial value of 1, which basically means, or we have an a value of 1, which means our initial value is 0, 1. Now that's going to move. So we have an initial value at 1. We're going to shift it left 1, down 3. And we have ourselves an exponential growth. So for us, we're just going to kind of sketch the graph. But basically this is 2.5. That means whatever this distance is going to be 2.5 times higher than what the original one was. And it's always from the horizontal asymptote. So this horizontal asymptote is a height of 1. And the next height is going to be 2.5 times bigger than that. So 2.5. And then we would take the 2.5 and multiply it by another 2.5. And that would get us our next point. So that exponential growth graph looks something like that. So our domain is always negative infinity to infinity. Graph's going to go left and right forever. Our range here has a horizontal asymptote of negative 3, and we go up forever. All right, so that's the first one. The second one. Don't like how that's written at all, so I'm going to kind of tweak this a little bit. So I'm going to make this a negative 1 for this number in front, so that's our a value, and then 1/2 with a negative x, and then plus 5 at the end. Now I don't like this either. This is a horizontal reflection. But you can basically apply that negative exponent into the base, into our multiplier. So if we did that, a negative exponent's going to do the reciprocal of this. So it's a negative 1, 2 to the x plus 5. So we have growth. We have our a value is negative 1. That's also going to vertically reflect, and we don't have any left or right shift, but we're going to have an up 5, which that up 5 is our horizontal asymptote. So we have a horizontal asymptote at 5. 1, 2, 3, 4, 5. All right, and so our graph should have been at a 0, 1. But our initial value, it would have been at a negative 1, and then we shifted up 5. 1, 2, 3, 4, 5. So our graph should have been here, which is your normal exponential growth, but we reflected it. And so our graph is actually going to head in this direction. And if I do this doubling, this distance is 1, so this one will be twice that. And then, so that distance is 2, so this distance will be twice that, which is 4. And then will be twice that. So instead of 4, 5, 6, 7, 8, we're going to be doubling that gap. And then if we go the other direction, we would be cutting it in half. So that is our exponential growth. Now, it doesn't look like it's exponential growth, but it's actually exponentially growing into the negatives. So it would be like debt. The national debt is exponentially growing into the negatives. So that is kind of our real life example of that. And then our domain is always negative infinity to infinity. And then our range here is actually from, because we always read ranges and domains from small to big. So it's coming from negative infinity and hitting a high point of our horizontal asymptote. And that's just a brief idea of graphing some exponential growth and decay problems.